And the answer here is the last two. The question of, is a program a virus, is a question about the program's behavior, as I've defined it. Also, some programs are viruses and some aren't. So this can't be decided in general. We can look for specific viruses, and we can monitor the behavior of programs for suspicious activity. Doing this is a billion-dollar industry, but we're never going to get an all-purpose virus detector. Nor am I ever going to be able to write the perfect test code to see if the Turing machine that you programmed to decide balanced strings actually works. I can write test cases and detect common errors, but I can never decide completely whether your programs are right or wrong. On the other hand, I can write a program to test whether your reduction of HTM to the language of Turing machines that accept nothing as decidable, I simply reject. Remember that no such reduction can exist because HTM is recognizable and ETM is co-recognizable. And lastly, this question about whether a program will halt in 10 to the 200 steps is decidable. I just run the program for up to that many steps. Of course, that number is so large that in practice, even on the fastest computers, the heat death of the universe will have occurred by then. But nevertheless, the question is decidable. The reason Rice's theorem doesn't apply here is because this question is about machines, not about languages. The purpose of this quiz is not to tell you that undecidability is a concept with no practical implications. Rather, it is to help you to see what it does and does not tell us. Just because a problem is decidable doesn't mean that it's tractable or practical to solve. Also, just because a question is undecidable in general doesn't mean that we can't write programs to tackle specific cases as we do every day with malware detection and software testing. It does, however, say that we should not expect an all-purpose solution, and any attempt to achieve that end is doomed to fail.